Hello. In this video, I will share a technique called hypothesis testing used to compare sample data to population data. In statistics, a hypothesis is a claim or statement about a property of a population, and a hypothesis test is a standard procedure for testing these claims. Here are two claims about populations that might be difficult to verify if we cannot measure each member of the entire population. The first is that a teacher claims that the mean score of a particular exam is equal to 75, which might be important to confirm the validity of a testing method. If the actual mean is different than this, the teacher may need to modify his or her test. Another claim by the FAA is that the mean weight of an airline passenger with carry-on baggage is 185 pounds. Of course, it is important to obtain the correct average weight when determining safe payload capacities of aircraft. One element necessary to consider when testing a hypothesis is the significance level, alpha. Recall that alpha is the complement to the confidence interval, and in this case, it represents the probability of making the mistake of rejecting the null hypothesis when it is true. This means that we reject the claim when it is actually correct for the population. This is a mistake that we would like to avoid, known as a type 1 error in statistics. There are several hypothesis testing techniques that should be used based on a number of different factors. For now, I will share the two-tailed hypothesis test technique when a population standard deviation is known. In some situations, a left-tailed or right-tailed test might be appropriate, or perhaps the population standard deviation is unknown and you have to rely on your sample standard deviation. These other methods will need to be covered at another time. In the first example above, we saw that a teacher claims that the mean score of a particular exam is equal to 75. Some additional information we need for the two-tailed hypothesis test is that the standard deviation of all test scores is 11, and the mean score of a sample of 30 recent students was 80. To complete the test, first we need to identify our null and alternate hypotheses. This will be our claim and the opposite of our claim. The results of a hypothesis test simply reject or fails to reject our initial claim. It does not prove that something else is true. I would say that H naught, or our claim, is that mu equals 75, and that HA, our alternative hypothesis, is that mu does not equal 75. Neither confidence nor significance level is provided, so I will use one of the most common confidence levels, 95%, which correlates to a significance level of 5%. For a two-tailed hypothesis, we divide alpha by 2 and use this to obtain the areas under a normal curve for two tails. This area correlates to a z-score of a positive and negative 1.96. You may remember this from a prior lesson. These areas to the left and to the right of the middle 95% represent our rejection regions. If our computed test statistic in the next step falls into one of these regions, we will reject the null hypothesis. Our x-bar value was 80 with an h-naught value of 75, a sigma value of 11, and a sample size of 30. With a calculator off screen, I compute this result to be about 2.5. .5 falls into our rejection region since it occurs to the right of 1.96. Therefore, we reject the null hypothesis. We must be careful with our language here. It may seem strange, but we did not actually prove that the alternate hypothesis is true. We only showed that the null hypothesis should be rejected. A deeper discussion on this can be had at another time. In the second example, the FAA claims that the mean weight of an airline passenger with carry-on baggage is 180 pounds. With additional information, such as the population's standard deviation is 50 pounds, and the mean weight of a sample size 500 is 175 pounds, we can complete a two-tail hypothesis test. What do you think H0 and HA should be? I'll say that H0 is mu equals 180, and HA is mu does not equal 180. For this example, I would like to use a confidence interval of 99% since we want our airlines to be confident in the weights used for payload capacity. Our significance level is 1%, and half of 1% is 0.005. We use this number to find our rejection region. This value falls at a positive and negative 2.575. Our test statistic must be 175 minus 180 divided by 50 over the square root of 500, which computes to negative 2.2361. This does not fall within our rejection region. Therefore, we fail to reject H0. The sample does not provide enough evidence to reject the claim that the average weight is 180 pounds. I hope these examples help you with your coursework. I know that learning the vocabulary and details of a statistics unit can be challenging. Do not be afraid to consult a variety of instructional tools for further assistance. Good luck.